for a single customer, we simply need to query that one partition. Now, it seems like that there is a bit of similarity between Azure Cosmos DB container and a table in Azure Table Storage in that data is partitioned, so documents and in Cosmos DB and rows in a table, and that they're both identified by some unique ID within the partition, but that's sort of where the similarity ends. So unlike Azure Table Storage, documents in a Cosmos DB partition aren't actually sorted by ID. Instead, Azure Cosmos DB maintains a separate index. So this index contains not only the document IDs, but it also tracks the value of every other field or the fields inside that document. And this index is created and maintained automatically so that you can use it to perform queries, such as trying to query for a particular field inside those documents in your container without having to scan through the entire partition or all the documents in that container to find the data that you're looking for. Now, Cosmos DB provides a couple of APIs to allow you to access the documents, and it also provides support for other NoSQL database management systems through these APIs. So these APIs are the Table API, the MongoDB API, the Cassandra API, the Gremlin API, and the Table API is essentially an interface that allows you to use the Azure Table Storage API to store and retrieve documents. The purpose of having this API is really to allow you to switch between table storage to Cosmos DB without requiring you to modify any of your existing applications. The MongoDB API is used to support any MongoDB databases that you might already be using for your applications. So MongoDB is another well-known document database. It's got their own programmatic interface, and many organizations actually use it on their premises within the organization. So you can use the MongoDB API for Cosmos DB to enable a MongoDB application to run against your Azure Cosmos DB without having to make any changes to your applications, so that you can migrate the data from your MongoDB database to a Cosmos DB database running inside of Azure and continue to use the same applications to access the data inside Cosmos. Now, the Cassandra API is used to support Cassandra, which is a column family database management system. So this is another database management system that, again, a lot of organizations run on premises. And the Cassandra API for Cosmos provides a Cassandra-like programmatic interface for Cosmos DB. So Cassandra API requests are mapped to Cosmos DB document requests. Just like the MongoDB DB API, the primary purpose of the Cassandra API is really to enable you to quickly migrate any of your existing Cassandra databases and applications without having to make many changes to it to Cosmos DB. And the Gremlin API, well, the Gremlin API implements a graph database interface to Azure Cosmos DB. So again, a graph is a collection of data objects with directed relationships, and data which is held in a set of documents in Azure Cosmos DB can actually be queried using the Gremlin API, which allows you to perform those graph-like queries over your data that's held inside your Azure Cosmos DB. Now, the principal use, the main use of Table, MongoDB, and the Cassandra APIs is really to support any of your existing applications that are already using these kind of data stores as their backend, as their data tier. So if you're building out any new applications and databases, you should really use the SQL API or the Gremlin API. So Azure Cosmos DB is very suitable for some of these scenarios. So if we're talking about retail and marketing, Microsoft actually uses Azure Cosmos DB for our own e-commerce platforms that run as part of the Windows Store and Xbox Live. And Azure Cosmos DB can actually be used quite extensively in the retail industry to, for example, store catalog data or for event sourcing in order processing pipelines. In the gaming industry, the database tier is quite a crucial component for gaming applications. So modern games perform graphical processing on mobile and console clients, but they typically rely on cloud services to deliver these customized and personalized contents like in-game stats, social media integration, and high score leaderboards. Games often require single millisecond latencies for reads and writes to provide that engaging in-game experience. And so a game database needs to be very fast, and it needs to be able to handle massive spikes in request rates, especially during new game launches or new feature launches and updates. Azure Cosmos DB is also able to support IoT systems and devices. So in IoT systems, typically a lot of data is ingested very, very frequently, because these data are being generated on a second-by-second basis. And so using Azure Cosmos DB, we're able to ingest and store this data very, very quickly. So then this data can be used by analytics services like Azure Machine Learning or Azure HD Insight or Power BI to then run analytics workloads on top of it. Additionally, you can also process the data in real time by triggering an Azure function to help filter and to process some of that data as well as it comes into your Azure Cosmos DB database. Lesson 2, explore provisioning and deploying non-relational data services in Azure. Now, there are a couple of ways we can provision Azure Cosmos DB. We can provision Azure Cosmos DB through the Azure portal, which we've already seen how we can do that with the Azure SQL database. So it's a similar approach using the Azure portal. We can also provision Azure Cosmos DB through the Azure command line interface or the Azure CLI. So typically you use the Azure CLI to execute CLI commands through either your command line prompt or through the Azure Cloud Shell. So CLI is suitable if you need to automate service creation. You can store CLI commands and scripts, and you can run these scripts programmatically. And CLI can actually run on Windows, Mac OS, and Linux computers. Azure PowerShell is also another way you can provision an Azure Cosmos DB. So if you're familiar with PowerShell, this is kind of the alternative to Azure CLI. So again, you can use PowerShell commands to script and automate tasks. You can also use PowerShell to create and manage Azure resources, just like CLI. And similar to CLI, it's also supported by Windows, Mac OS, and Linux. You can also use Azure Resource Manager templates or ARM templates to execute your deployments. Now, ARM templates is essentially a declaration of your infrastructure and its configuration and set up as code, so as JSON code. So this code that's formatted in JSON can then be used to deploy your Azure resources and provision your Azure resources like in Azure Cosmos DB. So let's take a look at how we can use the Azure portal to provision an Azure Cosmos DB database. So I'm on my Azure portal now, and I'm going to provision an Azure Cosmos DB account. Then I'm going to create a database inside the Azure Cosmos DB account. And then inside that database, I'm going to spin up a container for my documents. So again, I'm just going to look up Cosmos DB from my search bar. I'm going to click into it, and I'm going to go add. Now, I need to provide a couple of configuration details. Just like the Azure SQL database, that we set up earlier. So I'm going to start with the basics. I need to choose the subscription, which this Azure Cosmos DB will be deployed to. I also need to put it inside a resource group. So I'm going to look up the demo one that I set up earlier. Now I also need to give my Azure Cosmos DB account a name. This name needs to be unique. So I'm just going to say Cosmos and enter some random numbers. The API section is where you can choose what kind of API queries we want to use against our Azure Cosmos DB databases. So if I open up this drop-down, we can see that the core SQL API is supported, the MongoDB API, Cassandra, table storage API, and the Gremlin one. So I'm going to just pick the core SQL API. Now I'm going to leave notebooks switched off. It's still in preview. And for location, this is where I'm going to pick which Azure region I want to deploy my Azure Cosmos DB databases to. So I'm going to go and find East US because that's what I've been provisioning all my services so far. And then in capacity mode, you get to pick between provision throughput and serverless. Now, the difference between the two is provision throughput is essentially dedicated resources for your Cosmos DB to run. Serverless is essentially resources that will be provisioned to you when you need it. And so it's not constantly dedicated to you. So if you've got very light workloads or you're doing dev test scenarios, you can use a serverless option. However, if we're talking about production workloads, you should really consider using the provisioned throughput option because this will give you dedicated resources for your Cosmos DB databases. We can also apply a free tier discount to our Azure Cosmos DB account. Now, this free tier can only be enabled once per account per subscription, and you'll get 400 RUs per second and 5 GB of storage for free. And so RUs means request units, and request units, you can think of it like the computes and a whole bunch of other resources that is needed to actually run your Cosmos DB databases. And this actually increases as the throughput for your Azure Cosmos DB database requirements increases as well. And so if we apply this discount, we actually save around $24 a month. But I'm not going to apply it because I've actually already created an Azure Cosmos DB account, so it's not going to be applicable to me. I can also choose what kind of Azure Cosmos DB account this is. So is it a production one or a non-production one? I'm going to leave the non-production one because this is a demo Azure Cosmos DB. And here I can come and configure things like geo-redundancy, multi-region rights, and availability zones. So geo-redundancy, if I enabled it, this means that I'm going to replicate some of my Azure Cosmos DB databases to other regions, other Azure regions across the world. And so that means if my primary database somehow encounters some errors or a natural disaster happens, I can quickly and easily fail over to some of my other databases running in other regions that are not affected by this disaster, for example. Multi-region rights, if I enable this, it means I can actually create several master copies of my databases located in other regions around the world, other Azure regions around the world. And what that means is I can actually do write operations to multiple different nodes or databases across the Azure regions. And so if I enable multi-region rights, I can write to multiple master databases. Availability zones is all about provisioning an Azure Cosmos DB for high availability. So what that means is your Cosmos DB databases will actually be located into different availability zones, which means that they will be highly available. So if something happens to one zone, you'll guarantee that there is always going to be other running instances in some of the other zones. I'm going to disable and turn off all those features for now, just because this is a demo Cosmos DB. And I'm going to head over to the networking tab. Now, networking tab, similar to the Azure SQL database, this is where you configure the network connectivity. So we can choose from all networks, which means any networks around the world, from the internet, from Azure, from anywhere you're on premises, can access the Azure Cosmos DB. Or we can choose selected networks. So the public endpoint will allow you to only allow access to the Cosmos DB from a couple of networks, or we can select the private endpoint, which means we'll block off all public access to our Cosmos DB account. I'm going to go back and just enable all networks, and I'm going to head over to the backup policy. So backup policy is where you specify how frequently we want to make backups of our Azure Cosmos DB databases and how long we want to retain those backups for. And so you can specify that in the backup interval and the backup retention rates. Now I'm just going to leave all the default values and head to the encryption tab. So Azure Cosmos DB databases supports data encryption, and you can either use the Microsoft Service Managed Keys, managed encryption keys, or you can bring your own encryption keys to encrypt the data that is stored inside your Azure Cosmos DB databases. I'm just going to leave the Service Managed Keys because I don't have a key to provide my Cosmos DB account, and I'm going to head over to the tags section. So again, in the tag section, we can add some metadata to our Azure Cosmos DB account to provide more information about what this particular Azure Cosmos DB account is being used for. I'm not going to add any tags, and I'm just going to head over to Review and Create. That's going to run a small validation check just to make sure that some of my configuration details I've given it is correct and valid. And once that's passed, I can then go and create my Azure Cosmos DB account. So that's going to submit it to Azure to go and deploy my Azure Cosmos DB account for me. Now, once that has been deployed, we can then create an Azure Cosmos DB database, and then inside that database, we can create a container, which is where our documents will be located. And so, because in wary of time, I've actually set up a Cosmos DB to look at. So while this one actually goes and deploys, let's have a look at a Cosmos DB that I've spun up earlier. So there you go. I have one that I've set up earlier called my DB 900 Cosmos DB. So let's just go into it. And again, on the overview page, we can see some of the credentials and details about this particular Azure Cosmos DB account. So I can see, for example, where the endpoint to access my this particular Azure Cosmos DB account is, the region that it's been hosted and deployed to, and a bunch of other details as well. Now, if I go into the Data Explorer tab, this is like the Query Explorer tab that we saw in the Azure Cosmos in the Azure SQL database, but this one is for Cosmos DB specifically. So if I head into the Data Explorer tab, I can directly create some Azure Cosmos DB databases and containers from the Data Explorer. And as you can see, I've actually created a couple of databases already. So I've got one called Demo Database, and I have one called Volcano. So if we drill down into the Demo Database one, I can see that I've already got a container inside this particular database. So this container is called Demo Volcano Data. Now I can also come up here and create a new container. So I'm going to create a new container, and I need to give my container an ID. So I'm just going to call this my demo container. I need to give this container a partition key. So I'm just going to say this container's partition key will be ID for the data the document data I'm going to be uploading to this container. And the throughput is where we specify the number of RUs to provide this particular containers. And so we can see that the lowest start at 400 and the highest is 100,000 RUs we can provision for this particular container. So you can choose between manual, which means if I specify 400 RUs will provision to this container, or I can pick auto scale, which means the RUs allocated for this container will automatically scale depending on our workload needs. And so I'm actually going to turn that off and go back to the smallest one. I can also configure analytical store, so I'm just going to leave that off for now, and I'm going to click OK after that. And that's going to go and then create my container for me inside my Azure Cosmos DB database. The data migration tool can be used to input data to your Azure Cosmos DB from a variety of sources. So it's available to be downloaded from GitHub, and the tool actually guides you through the process of migrating data into your Azure Cosmos DB databases. So you're prompted for the source of data inside the Azure Cosmos DB migration tool, as well as the destination, which is essentially the Azure Cosmos DB database and the container that you want to migrate the data to. So the tool can be used to either populate an existing container or create a new one if the specified container doesn't exist already. And you can also use the data migration tool to export data from an Azure Cosmos DB container to a JSON file that can be either locally hosted or hosted on Azure Blob Storage, for example. If you have a lot of data, the data migration tool can also make use of multiple concurrent threads to batch your data into chunks and then load those chunks in parallel. So let's take a look at how we can use the